Hi guys, welcome back to my channel. In my previous video, I have covered what is AWS Lambda and how we can create serverless API using AWS Lambda and API Gateway. But that API was kind of hello world API. So in today's video, we will create a serverless CRUD API using AWS Lambda, DynamoDB and API Gateway that will be responsible to create, read, update and delete ToDo items. And then we will be calling our newly created API from Postman. And in today's video, we will be using AWS Lambda and API Gateway. So if you want to get basic understanding about these, then please watch my previous video and you will find the links in description for the same. Okay, first we will see what is DynamoDB, and then we will create a DynamoDB table to store ToDo items. And then we will create a normal API in .NET 6, and we will create endpoints to create, read, update and delete ToDo items in DynamoDB table. And then we will convert this simple .NET API to AWS Lambda function with minor changes. And then we will deploy this Lambda function to AWS using Visual Studio. And then we will create an API in AWS API Gateway with CRUD routes for ToDo, and we will attach our newly created Lambda function with these routes. And then we will call this API from Postman. So if you are new to this channel, then don't forget to subscribe and press the bell icon to never miss out on my videos. So first of all, we will see what is AWS DynamoDB. So AWS DynamoDB is a type of database that can store a lot of different types of data like text, numbers and pictures. And it's really fast and can handle a lot of people using it at the same time without slowing down. It's also really easy to use and it can automatically adjust itself as we add more data. We can use it to build all kind of different types of application like website, mobile apps or video games. DynamoDB doesn't use traditional tables, which makes it very flexible and adaptable to different data structures. Table structure will automatically be created while first insert in the table. And DynamoDB has advanced features that let us do complex things with our data, like updating it only if certain conditions are met and automatically deleting all data. Now let's create a DynamoDB table to understand more about it. To access DynamoDB in AWS, we'll go to AWS console and there we will search DynamoDB. And here we will create a new table. So as per our requirement, we will create a table with name ToDo, and we need to provide a partition key, and it's like a primary key, so we can name it like ID. And this sort key also we can provide, but partition key and sort key should be different and it is optional, so we will keep it blank here. And these table settings will be default, and just we will create new table. Yeah, table is created, but we haven't provided any schema for this. Means what will be structure for that? So table structure will be created on first insert. So we will insert a data in this table. So structure will be ready. So for inserting a row manually, we will go to this create item. And here there will be a column already available ID, and suppose this is 1, and we will add new attribute. And it is asking for data type, so we will add a string data type and column name will be details and data is ToDo1, and we will just create it. So our data is inserted, and now you can see table structure is defined, ID and details, and you can see here there is a particle editor, and here we can run queries on DynamoDB table, and these particular queries are SQL compatible, so we can use queries same as SQL queries. So for our table we can just write select star from ToDo because our table name was ToDo. We can just run here, so it returns the data. So these queries will be same as SQL, so we can do our things here. And here is a backup option, and there is two type of backups here. First one is on-demand backup that will be created instantly, and other one is scheduled backup that will backup our data periodically, and we can configure the period while backup creation, and we can also set expiration time for the backup, and backups will be automatically deleted when it expires. And we can also export the data to S3. We need to provide S3 bucket name while export, and we can specify the file format here. And we can also import the data from S3 to DynamoDB, and we need to provide S3 bucket name from where we will import the data. So our DynamoDB is ready. Now let's create an API. So for creating API, we will go to Visual Studio, and this is a blank solution, and here we will add a new project, and that will be ASP.NET Core Web API. Next, and we will name it ToDo API. Next, and framework will be .NET 6. Yeah, so basic API is created here. So we will do our changes, means we need to create a ToDo API to support all the CRUD operations. We will create a new controller here. ToDo. And here we will create some endpoints, like first we will create post, and before that we need to install some NuGet packages to support AWS DynamoDB. We will install DynamoDB. This one. And we will install AWS.NET Setup. Yeah, and we need to register these services in program.cs. We will add DynamoDB services here. Builder.services, add AWS service Amazon DynamoDB, and second one is builder.services.add scoped DynamoDB context, and then its class. And we will inject this interface in our controller. Private read only context. And here we will create post method. So in this post method we will receive our ToDo data. So for that we will create a new class. So suppose our class name is ToDo, and this class will be referenced to DynamoDB table. So we will add an attribute for DynamoDB table, and here we will pass its name. So DynamoDB table is ToDo, and here we will have two columns, public string ID get set, and we will reference this column as well with Dynamo. We will add DynamoDB has key attribute here because ID is our primary key, and we configured it as has key while creating the table. And next column we have details. And here as well we will provide DynamoDB property and its name details. Yeah, so our table reference class is created, and now we will receive its input in post method, and we will make this post method as async task. And here first we will check if the ToDo IDs already exist, then we will return a message, otherwise we will insert that. So for that, first we will get our existing ToDo context.load async, and in this generic we will pass our class name, and here we will pass our hash key value. So our hash key is ID, so we will pass todo.id, and we will add a wait here. So if existing ToDo, so if this is not null, it means that IDs already exist, so we will return bad request. IDs already exist, otherwise we will insert this data. Context.saveAsync ToDo, and in this we will pass our object, and here we will use a wait. And in return we can just return this ToDo object. So our post method is created. Now we will create a put method, and here we need to provide route controller base and API controller, and now we will create our put method. So in put method we just need to update our ToDo data. So for that, first we will check if that ToDo IDs already exist, then we will update, otherwise we will return that this ID is not exist. So if not exist, then we can just return not found. ID is not valid. If it is exists, then we can just update that. And for save as well, we just need to do the same thing, save async. After that, we will create a get method to get all get. There will be no input parameter here, and we will just get the data existing ToDos, and for getting all the data we need to call scan async, and here we need to pass default because we are not searching anything here, and after that get remaining async, and we will return this. We can do one more thing here. We can just check if this existing ToDos are not null, then we will return, otherwise we will return not found. And then we will create a new endpoint that will receive an ID in input, and we will return the respective ToDo item. For that, suppose we have this ID, and here we will provide ID in routes. So to get existing ToDo, we need to call load async, and here we need to pass our ID, and if existing ToDo is available, then we will return OK, otherwise not found. Now we will do one more thing. We will create one more method to delete ToDo items. Delete, and that will receive ID in input which we need to delete, and when we are going to delete this, then we need to check if it is already exists, then we will delete, otherwise you will return not found. So in this condition it is already exist and we just need to delete it. So we will call await context.delete async existing job. Okay, and we will return OK, means it is deleted. So I think our API is ready. We will just remove these two classes from here because we don't need them. Okay, let's check these in Postman, how it is working. Yeah, our API is running now. So let's check. So this is our endpoint, and suppose we are passing these details in data. So let's check. And yeah, so it is returning 200, and let's see these data in DynamoDB, these tables, and this is our table, explore table items, and here we will run it. So here there are two records. So first one we created here from manually, and the second one is created from our API. And let's update it. So this is our endpoint, and we will hit it with the updated data. So it will update details of this 3 ID. So let's refresh this. Yeah, so this is updated, and let's get all. Yeah, it is returning both the items, and in our get endpoint with ID, so it is also returning the correct data. So let's delete this data. ToDo, it returned 200, so it means our data is deleted. So we can verify in get API. Yeah, there is one record, and we can also verify from DynamoDB table. So that record is deleted. So this is how we can just create a normal API with DynamoDB, and now we will convert this API into Lambda function. To do this, we need to install one NuGet package, Lambda hosting. We will install it. And in program.cs we need to add a service for that. So here we will add builder.services.add AWS Lambda hosting, and with HTTP API we need to add Lambda hosting service to run the ASP.NET Core Lambda function in AWS Lambda. And now we need to do one more thing. We just need to update our CS pros with one key AWS project type. And here we need to pass Lambda. So we need to add this AWS project type property in CS pros file to indicate AWS Toolkit for Visual Studio to know that it is Lambda project, so we can publish Lambda functions from Visual Studio. So once we save this, it will create this publish to AWS Lambda menu here. So now we will deploy this Lambda function to AWS using this method. So let's do that. So it will ask some things like what will be runtime. So our runtime is .NET 6, and we will name our function ToDo API Lambda, and we will keep all the default here. Now before that we need to provide this handler. Handler name will be our project name. So ToDo API, and here we need to choose permissions. So we will set it like basic permissions, AWS Lambda basic execution role, And to access DynamoDB, we will provide that permissions later from AWS console. So we will just click on upload. It will upload our Lambda function to the AWS. Yep, Lambda function is created. Let's see in console. So this is our Lambda functions window. Let's refresh this. Yeah, the function is created. So in configurations, we can see it created a new role. So we need to provide DynamoDB access to this role. So we will add a permission here. DynamoDB full access. We will provide full access. Yeah, so permissions are attached. Now our Lambda function is ready to use, and let's create an API in API Gateway to access this by APIs. So let's build an API. We will name it ToDo API. Review and create. So we will just create it, and here we will create our new routes. So suppose our first is first method, and that route is ToDo, and next is put, and that is also ToDo. And third route is get, and first one is for get all, so that will be ToDo only, and one more to get by ID. So in that we will receive an input ID dynamically. We can pass dynamic route parameters like this, and then we will have a delete method. So that will also receive an input parameter in route parameters. So this is how we can create routes, and now we will integrate these routes with our Lambda function. So let's go to integrations. So first we will do integration for this get method, and here we will choose type of integration. Type is Lambda function, and here we will choose our newly created Lambda function and just create it. Now we will attach this integration in all of the routes. Get, yep, so all the routes are attached with Lambda. So now our API is ready. So let's check this API in Postman with AWS link. So this is our AWS URL. So let's go to Postman, and here we'll post this data. So this returned 200. So let's check this data in DynamoDB. Let's refresh it. Yeah, record is created here, and now we will call put method updated from postman with API Gateway link. The record is updated, and now let's get all. So both the records are coming here, and let's check get by ID. So it returned a newly created ToDo item, and let's delete it. So it returned 200, so it is deleted, and let's check in DynamoDB. Yeah, that record is deleted. So this is how we can create serverless CRUD API using AWS Lambda, API Gateway, and DynamoDB. I hope this video was helpful in understanding Lambda function, API Gateway, and DynamoDB uses. So if you have any questions, feel free to ask in the comments below. And thank you for watching this video, and I will cover some more interesting topics in my upcoming videos, so please subscribe the channel.